You know that feeling, right? You've built this awesome Python script, it works perfectly on your machine, and then someone enters one unexpected thing and the whole program just explodes. It is so frustrating. Well, today, we're going to fix that for good. We're going to learn how to turn those fragile scripts into rock-solid, fluent programs that can handle whatever the real world decides to throw at them. Let's get into it.
Ah, yes, the infamous wall of red text. We have all been here. You run your code, everything seems fine, and then, bam, a traceback error. It's basically Python's way of throwing its hands up and saying, I have no idea what you want me to do with this. It feels like a failure, but really, it's just a signpost, pointing us exactly where we need to go to write smarter, better code.
So, here's our game plan for today. First, we'll figure out why our code breaks in the first place. Then we'll learn the secret to catching those errors gracefully. After that, we're going to teach our code how to read and write files. And finally, we'll get into handling more complex structured data. Let's kick things off with part 1.
All right, section 1, when code goes wrong. To build programs that don't break, you have to think like a detective. You need to understand the crime scene, and in the world of code, that means knowing the two main ways a program can fail. Because, believe me, not all errors are created equal.
And this is the fundamental difference right here. On one side, you've got syntax errors. These are just mistakes in the grammar of the code, a missing colon, a typo in a keyword. Python sees this and won't even attempt to run your program. But on the other side, you have exceptions. This is when your code's grammar is perfect, it starts running, but then something unexpected happens. These are the runtime errors, the real-world problems, and they're the ones we're going to learn how to tame today. So let's meet the usual suspects. You're going to see these a lot. There's name error, which is just you trying to use a variable you forgot to create. A type error is like trying to add a word to a number. It just doesn't make sense. The value error is the one we saw at the beginning. Right type, a number, but the wrong value, 10. And of course, the classic zero division error, trying to break a fundamental law of math. Getting to know these is step 1. Okay, so we know what can go wrong. How do we actually deal with it? Well, we shift from just letting our programs crash to proactively managing the chaos. This is all about building a safety net right into your code, anticipating the problems before they happen. And our number one tool for building that safety net is the try except block. It is so simple, but so incredibly powerful. You just tell Python, hey, I want you to try running this code, but be warned, it might be a little risky. If something goes wrong, instead of crashing the whole show, the program just calmly jumps over to your accept block where you get to decide what happens next. The error is handled and the program keeps on running. It's a game changer. And here's the whole shebang. You've got your try block, that's your main plan. Except is your backup plan for when things go south. Then you have this handy else block, which runs only if try succeeded. It's like a little victory lap. And finally is the cleanup crew. It runs no matter what, success or failure, which makes it absolutely perfect for things you always need to do, like closing a file.
Okay, theory is one thing, but what does this actually look like in the wild? Let's take a super simple script, like a BMI calculator, and see how we can make it totally bulletproof.
And this is really the magic of it. Imagine the original script. A user types in 6 feet when it's expecting a number. The old script just dies. Value error. Program over. But now we wrap that risky input part in a try except block. We catch that exact error, and instead of crashing, our program can print a friendly message like, oops, please use numbers only, and then loop back to ask again. That right there is the difference between a fragile toy and a robust tool.
Okay, fantastic. Our code is now stable. It can defend itself against bad user input. So let's give it a new power, the ability to interact with the world outside of itself. Let's teach it how to read and write files.
Now, when it comes to files in Python, there is one golden rule, one thing you absolutely must use, the with statement. Think of it like a self-closing door. It opens the file for you, lets you do whatever you need to do, and then it guarantees that the file gets closed properly when you're done, even if an error happens. This is so important for preventing corrupted files and other weird issues. It's the modern, safe way to do it.
So when we open a file, we have to tell Python what we plan to do with it. These are the 3 modes you'll use 99% of the time. R is for read, you're just looking. W is for write, but be careful, this one will completely overwrite the file if it already exists. And A is for append, which just politely adds your new stuff to the very end of the file.
So let's actually write to a file. It's surprisingly easy. First, we open our file using that all-important with statement and the W mode. Then we get our data ready. Let's say we have a list of names. We just loop through that list, writing each name to the file one by one. And that's literally it. The with block takes care of closing everything up for us. It's so clean. And reading is pretty much the exact same process, just in reverse. We open the file again, this time in read mode, R. We make an empty list ready to catch the data. Then we loop through the file, and Python is smart enough to give it to us line by line. We just grab each line and append it to our list. Simple, effective, and now our program can read. So, we've nailed plain text files, but a lot of the time, data isn't just a simple list. It has structure, rows, columns, like a spreadsheet. So now it's time to level up our skills and tackle structured data. Take a look at this. This is a classic CSV file, which stands for comma-separated values. It's basically a spreadsheet saved as a simple text file. You can see it's got columns and rows, just like you'd expect. Now, trying to pick this apart yourself, splitting on all the commas, that could get messy fast. Luckily, Python has a much better way. And that better way is Python's built-in CSV module. It's a specialized tool that's been designed to understand exactly how these files work. You don't have to worry about commas inside of quotes or any other weird edge cases. You just hand the file to the CSV module, and it does all the hard work of parsing it into clean, usable rows for you. It's a massive time saver. And here's the payoff. With just a few lines of code using that CSV module, we can effortlessly open up our inventory file and pull out just the data we need. In this case, a clean list of all the product names. No manual string splitting, no headaches, just the data we want, ready to use. And that's it. Let's just step back for a second. We started with fragile scripts that would crash at the slightest provocation. Now, we know how to build in safety nets, how to teach our code to read and write, and even how to understand structured data. Our code is no longer fragile. It's fluent and ready for the real world. So the only real question left is, what are you going to build with it?